we'll see that I've been in the space, as it were. I want to talk today about the politics and policy around climate change. This is an area where there's a lot of bad news for good reasons, but there's also a growing amount of good news that's getting lost because we don't know how to think about the good news. What I want to do today is introduce some of the good news and talk about why it's happening. I'm often in the room with these climate negotiations. Lisa Levin here, a colleague of mine from Scripps Institution of Oceanography, is also often in the room. We have a delegation that's going there to the COP28 in Dubai in weeks, actually days maybe. I'm going in a few weeks. That will be particularly focused on ocean-related issues. It'll be in the press a lot. And I'll talk a little bit about that along the way. First, I think our standard message around climate change is a twofold message. First, those of us in climate science, it's not encouraging. Here we are. Those of us in climate science know that the climate is warming and that humans are responsible for that. It's kind of a riff on Pogo, right? We've met the enemy and the enemy is us. This is from the last big report of the Intergovernmental Panel on Climate Change. This is the group of scientists that won the Nobel Peace Prize, shared it with Al Gore for work on climate science. I've been very heavily involved in this institution over the years. This shows the historical record of temperature going back to the year 0. Now, Jesus was not walking around with a thermometer, might have been walking around with other things, but not a thermometer, so you have to use proxies earlier years, and then actual measurements later on, and then satellites since the late 1970s, and so the error bars and the measurements go down, but the temperature goes up. And here's what happens if you try and simulate that record with our climate models, and you simulate the record, but you don't tell the climate model that there's been this buildup of greenhouse gases in the atmosphere. You get this line on the bottom here. Then you tell the climate models there is this buildup of greenhouse gases that's due to humans, and you can explain the historical record this way and you can't this way. And there's about 5 standard deviations between the two, and that's how we have enormous confidence. So on the one hand, the problem is very clear, we're responsible for it. The other hand, we're not on track to stop warming at 1.5 degrees centigrade above pre-industrial levels, a widely discussed goal. It's a little inconvenient that this year we're actually already at 1.5 degrees. It's an El Nino year, so the planet's a little bit hotter as a result of that, but it's not so convenient. This is from a big study that is part of the set piece for this big UN conference that's about to happen. You're going to see this in the news a lot. This is what's called a stock take. This is an effort to look at the overall global picture and the emissions from the planet, which is shown in this line here. And then these are the scenarios needed to stop warming at 1.5 to 2 degrees centigrade. This is kind of the trajectory that we're on right here. Not so great. And for that reason, you're going to see a lot in the news about how we're failing to make progress. We're going to fail to meet our widely discussed goals. It is true we will fail to meet our widely discussed goals. The goals were set in a way that it was never possible to meet those goals. When you set a goal through a global committee where everyone has to agree, but nobody is individually responsible for that goal, you end up with an ambitious goal that nobody's individually responsible for, and that's the picture that we have right now. But I don't think that's actually the right way to think about the problem. The right way to think about the problem is not that we scientists are now really sure that humans are causing this, and therefore humans better wake up and follow what we tell them to do. And it's not to complain that we're not meeting widely discussed goals. The question is, are we making progress? And that's the theme that I'd like to develop tonight. So I'm going to try and say 6 things tonight, but I'm going to only spend 30 minutes doing it, so I might give myself a hook on 1 or 2 of these things along the way. About signs of progress, kind of a little more hopeful vision, and why that's happening. Because a new theory of change about how you solve global problems is now emerging. That theory of change was worked out in large part actually here at UC San Diego, and it's having an impact. It's not going to stop warming at 1.5 or 2 degrees, but that was never realistic, but it's now starting to really change. And what I want to do is give you some ways of thinking about what's happening, but then also show you things to watch for in the data. And anyone who wants the slides afterwards, just send me an email and I'll send you the slides. Now, if you want an action photo of me pointing to the slides, then you have to take the photo, but you're also welcome to just send me an email and I'll send you the slides, the PDF. First, how do we know we're making progress? One way to think about progress is to ask yourself, 10 or 15 years ago, what was the world on track to do in terms of climate change? The answer was 4 or 5, maybe 6 degrees C of warming above pre-industrial levels. So much climate change that nobody even really knows how to estimate the physical impacts of that. I mean, just catastrophic. Today, the world is on track for about 2.5 to 2.7 degrees of climate change. That's kind of where our internal group thinks the trajectories are right now. Now, that's a lot of climate change. I'm going to talk about that at the end. We are in for significant climate change. We have to get ready for it, and that means that's a global question, that's a local question. I'll talk about that. We are grappling with that on the seashore here in Solana Beach. But it's not 6, it's not 5. And that's actually the way to measure, to think about progress, is it's not 5. Now, it's not 5 for a bunch of reasons. Some of them are climate policy, because of a new theory of changes now emerging and technological progress. Some of them are other macroeconomic changes. The most important one is the slowdown of the Chinese economy. The Chinese economy has fundamental structural weaknesses. And the Chinese economy has been the single largest source of growth in emissions of carbon dioxide. That's not to disparage the Chinese. They're growing economically. India is in the process of doing something similar. But there's a lot of different factors, but one of them is policy. And so we are, in fact, making progress when we measure progress the right way, not against some global goal set by a committee where no one was individually responsible for meeting the goal, but progress against the direction we were headed before we started really working on the problem. So the question is, why are we making progress? So I want to talk a little bit about a theory of change and what to watch for. There's a terrific piece in the current Wall Street Journal here we go. Thank you for the props right here.
Unpaid prop assistant. Exploitation.
Thank you. Get a hand
She's
for the
married to a lawyer there.
There's a piece in Wall Street Journal today. There's a piece coming, I think, in the Washington Post tomorrow on a similar topic. Times is covering this on a regular basis and so on. How do you connect all the dots inside the news? And so that's what I want to try and help you with tonight. First, what does it look like technologically to transform the economy so that emissions go down? And let me just give you a sense of how much you have to reduce emissions. Normal pollution, like pollution that comes out of the back of cars or acid rain, normal pollutants are what are called flow pollutants. The flow of the pollution into the atmosphere, into the waters, causes harm. And then if you want to stop the harm, you reduce the flow. And then very quickly you see a response. The main gases that cause climate change are not flow pollutants, they're stock pollutants. They're caused by the buildup, the slow buildup in the atmosphere of the pollutant. Carbon dioxide is the leading culprit. It has multiple lifetimes, call it about a century. And so when you've got a flow pollutant, if you just stop the emissions into the atmosphere, the pollutant is still up there. And so you have to not just make modest reductions in emissions, but deep reductions in emissions. We have this initiative, this joint between Scripps and the school that Peter is the founding dean of, school today called Global Policy and Strategy, and the School of Engineering on deep decarbonization. Deep decarbonization is getting essentially to zero emissions because we have this stock pollutant. Shallow decarbonization is 20–30% reductions in emissions. We know how to do shallow decarbonization. Deep decarbonization, we don't know how to do. And the uncertainty is not actually a reason for inaction, it's a reason for a particular style of action, and I'll talk about that. So what does it look like to do deep decarbonization, to make these kinds of cuts in emissions such that essentially global pollution levels are nearly zero and warming eventually stops? Not at 1.5 or 2 degrees, but eventually stops. So there's been a lot of work on this question. The building of models to answer that question is a perpetual employment program for academics, so it's great. And I'm going to show you some results from one of those models, which is an organization, the International Energy Agency, that puts out an outlook every year out of Paris. I'm a reviewer and a designer of this, and so I'll just show you one of the many, many results. But the results are starting to rhyme. They're very, very similar. The way you read this chart is you read from right to left. So on the right side, these are the emissions from different sectors of the economy. Electricity, heat, industry, transportation, who's driving around, flying, trucks, ships, and so on, buildings, and other. So here are the emissions in billion tons of carbon dioxide today. And then here's what you need to do. The green lines, for example, are what's called net zero, where the whole world essentially stops polluting. And what has to happen in each sector. What's interesting is to focus in on a couple sectors that are going to do a lot of the work here. Electricity and heat and transportation. The single most important thing to watch for progress on decarbonization is the electric power sector. The electric power sector today is the largest emitter of greenhouse gases. And every model shows that if you want to make big reductions in emissions, on the global economy, you start with the electric power sector. Why? Because it's easier to electrify lots of end uses. How many of you have electric vehicles? Right, so to electrify your vehicles, we're not yet at the point where we have an extension cord long enough for an airplane, but electrify your vehicles, electrify all kinds of industrial applications, and then make that electricity in the cleanest way possible, with a limited number of power plants on a grid that's highly reliable and so on. So that engineering insight is why every model shows that an economy that decarbonizes is an economy that electrifies. The place to watch is the electric power sector. So big reductions, in fact, to negative emissions from the electric power sector. There's one plant right now in the world that will be more, that burn biomass. So photosynthesis pulls carbon dioxide out of the atmosphere, you grow the trees and other materials. You take that, pelletize it, or turn it into some other form, and put it inside a power plant. And then you get electricity and heat out of the power plant, and then you capture the carbon dioxide that comes from burning the biomass. And so the plant actually generates what you want, electricity and heat, with negative emissions. That technology might scale a lot, it might not scale, we don't really know. But the models like those kinds of technologies. Huge reductions in transportation, almost to zero. The number one problem right now in transportation is aviation. I'll talk about that in a little bit. We do not have a solution on the aviation side that scales. We have solutions on the aviation side that pretend to scale, but we don't have solutions that really scale to global big reductions in emissions. So that's what it looks like from the perspective of an analyst. When you look at the real world and you ask yourself, what's really going on with investment, the picture begins to get really encouraging. Let me just show you a little bit of data. These are data put out every year by an arm of Bloomberg. And they calculate, they estimate the total amount of investment in all clean energy forms every single year. Last year was the first year that total investment in clean energy exceeded total investment in traditional fossil energy. Every major data set shows that to be true, including the Bloomberg data set. And so you see this incredible surge. What's amazing about these data is we had this pandemic. You may have remembered the pandemic. It happened in here. I'm trying to forget the pandemic. In the middle of the pandemic, in the middle of a period of tremendous economic turmoil, you saw an explosion of investment in clean energy. Why? Because the business model around many kinds of clean energy is more reliable and more durable, even in the middle of this macroeconomic shocks, compared to the business model around investment in traditional fossil energy. What's going on in the oil markets right now, I'm happy to answer questions about that. We study that pretty closely. But the overall picture is actually pretty extraordinary. And then all that happened, and in fact accelerated in the middle of the pandemic, is incredible. The other thing that's interesting about these data here is the colors correspond with different kinds of investments. And most of this bar for 2022, vertical axis here is billions of dollars, $1.2 trillion. The vertical axis here, this is renewable energy, solar and wind, and this is electrified transport. Almost all the investment right now, 85 to 90% of the investment is going into just solar and wind and electric vehicles and their charging systems. Why is that? Because those are areas where the technology is most mature. And so one has to watch as an analyst for where are the technologies not just becoming interesting, but becoming interesting in a way that an investor would put their capital into the project and be reasonably confident they're not going to get destroyed financially. That's why you see in the newspaper a lot of talk about fun things like hydrogen, carbon capture and storage. I spent all day at Stanford at a carbon capture and storage conference. The ratio of newspaper articles on carbon capture and storage to actual deals is very high because the denominator is nearly zero and the numerator is huge. Electrified heat is beginning to take off and all these other things that you read a lot about but are not yet mature. So we have to watch closely for which technologies are getting mature and attracting massive amounts of investment. It's popular to say these days that government's going to pay for all of this. We're in the middle of maximum government spending on clean energy in the Western world, and we have for a long time been at that state in the Chinese world. But if you add up the total $1.2 trillion that was invested last year, at most $400 billion or so of that was government money. My own view is that the government spend is at a high watermark. It's not sustainable. And so the real trick here is how do you turn these ideas of new technologies into projects that can really be funded and financed as normal project finance. Why is all this happening? One of the places happening that's most striking is in electric power. Every year, Lazard, which is a little out of date, the new one's very similar, Every year Lazard puts out a study that shows the cost of electricity from different sources of energy, clean energy. So down here you see the conventional ones. Here's a nuclear plant. This is an existing nuclear plant. This is a new build nuclear plant. Horrifying to think about new build nuclear right now from a financial point of view. Various kinds of natural gas. And then here are the renewable sources up here. The reason so much money is going into solar and wind is because large-scale onshore wind costs about $40 a megawatt hour. That's about the same cost or a little bit less than a conventional natural gas plant. And large-scale solar is even cheaper than that. So there's a tremendous technological progress in these areas. It doesn't guarantee that that's going to be the only technology you choose, and you've got to run the grid in a way that's reliable, so you have to integrate different sources and worry about stability. But that picture has really changed dramatically. That's a source of incredible progress. When you study the history of technological change, you often see S-shaped curves. You see curves where if you measure the diffusion of a technology, the market share of a technology over time or over effort, it starts off in a really small stage and then eventually takes off and diffuses rapidly and widely and then saturates. Why do you care about this? You care about this because if you want to be seeing the progress of different technologies, you want to be looking for these S-shaped curves and trying to figure out where we are in the curve. Most technologies spend a lot of time in the wilderness learning how to walk. Over here, think of the early, how many of you bought your electric vehicle before the year 2015? One person. What was the experience? You bought a hybrid, well, that doesn't really count because they're like part.
Early generation, it doesn't go very far.
Yeah, so these experiences, some people go off and buy these technologies early, and God bless them. But they are the folks who, they're pioneers, the people who help bring down the learning curves. They're tolerant of the car if it catches on fire because all the batteries blow up. They pull it on the side of the road. They buy another one. They say, well, you know, it didn't work out so well. And this is the wilderness period. And then as the technology matures, it really takes off. And as a political scientist, to me what's interesting is as the technology matures, the politics also change. Because the technology, as it gets better, becomes more competitive, it gains market share, which means it gains excess revenues, it means it gains political allies. And that's the theory of change that's taking place right now, which is that we're investing in new technologies, we're adopting policies that push those in various ways, and as the technologies get better, the politics also change. And that's really key, I think, to understand. And the further along you are, the more you have these feedback loops that include politics and regulation. So not surprisingly, the technologies that are further along in the electric power sector and vehicles are attracting a lot of investment and also attracting a lot of political allies that we see on display all the time. I want to show you some data about what's going on in the real world. These are market shares for renewable electricity, solar and wind, and market shares for new electric vehicles in major leading markets. What's interesting is all these curves look an awful lot like S-shaped curves. In fact, we see this over and over and over again. It's for the mature technologies that are now in the takeoff phase, and they're taking off very rapidly. The other technologies are way down here in the earlier parts of the S-shaped curve. Electric vehicles are particularly striking. Norway, whenever you see somebody doing something great for the world in a seemingly selfless way, they're almost always Norwegian. And so the Norwegian policy environment for electric vehicles was so generous. You could basically drive your car anywhere you wanted to. You could avoid tax, you didn't have to pay for parking, on and on and on. So not surprisingly now, 85% of new vehicles in Norway are electric vehicles. Tesla's largest dealership outside of California was in Oslo, because everyone wanted to have an electric vehicle because it was cheaper than buying a fancy Volvo. You just buy a Tesla and you get to feel good about yourself, and the government pays you to feel really good about yourself. So not surprisingly, they were kind of a big pioneer, but along the way, others have improved. This insight tells you something about what to expect for the technologies, which is different technologies are at different stages on this S-shaped curve. And that means we should have different expectations for the rate at which they grow and different policies. If you're here on the takeoff phase, the policy that you need is a policy that creates a tax incentive or simply tax the carbon pollution so that the old technology becomes less competitive. And the technology on its own will largely take off, not completely. But if you're way down here on the left side, the policy environment is different. It's industrial policy. It's working in a bespoke way in the steel industry, which is different from aviation, which is different from shipping, and on and on and on. This is a chart that takes that S-shaped curve and orients all 10 sectors that are responsible for most global emissions as to where they are along the S-shaped curve. It makes the argument that you're going to need different policies and strategies for different different sectors. This was the mental model, the intellectual model the British government carried into the big COP26 conference that happened in Glasgow a few years ago, where they said, hey, when you host one of these conferences, you have to do the diplomacy right. People have to come here, they have to feel good, they have to go home with an agreement, not get angry at each other. And so there were endless discussions literally about comma placement in sentences. That happens in 6 languages, with consensus as the outcome. And sometimes you don't get consensus. This next conference is about to happen. Maybe one of those conferences where we don't get consensus. It could actually fail formally. But in addition to that, what are you doing to create new facts on the ground, to create new technologies in key sectors? And that was what the question the British government wanted to know the answer to. And their answer was, well, let's get the top firms and the top governments in each of these sectors and have them make a club. Little clubs of pioneers that would go off and invest in new technologies and learn how to work these new technologies, and by doing that, move their technology along the S-shaped curve and change the politics on the ground. And that is what's now happening, and it's working. It's really working. That is laid out in a couple of different things. This is a book that just came out that Peter mentioned in his introduction with Chuck Sable, Columbia Law School, that lays out the theory of how you deal with these kinds of technology, the need to invest in different clusters of technologies and how we manage uncertainty and so on. And then there's an article about a year ago in Foreign Affairs that lays this out and applies it to the diplomacy. I think it's having an impact. I want to just emphasize, though, a big part of this is around the politics. And I think one of the things that is worrisome is we have take tonight. All of us are self-selected folks who are worried about the climate change problem. How many of you, on a reasonably regular basis, read the Wall Street Journal or the New York Times or the LA Times or the USA Today or any of the other kind of top 8 or so media? Okay, congratulations. This is a paper that's just going into review today, I believe, where we looked at all those elite newspapers. We said, how much are people talking about climate change in the elite news outlets? That's shown in the blue line here. This is a fraction of all articles published that deal with climate change. And there's a lot of measurement problems here. Measurement problems are also known as employment for those of us who try to analyze measurement. So we spent a lot of time on that problem. Here's the blue. The red is an amazing data set called Media Cloud, which covers 26,000 news outlets all around the United States, mainly state and local, mainly in the heartland of America. Back in the 2010s, the probability that there would be more talking about climate change in the heartland newspapers than in the elite newspapers, about 1 day in 3, just randomly. It's a huge data set, several million data points, and so it's wonderful for doing statistical work. Probability is 1 in 3. Today, the probability that on any given day or multi-day period, there'd be more discussion about climate change in the heartland newspapers compared with elite newspapers is about 1 in 50 or 1 in 60. Wow. So there's been this just huge divergence, and it's happened for a bunch of different reasons. It's the left-right divide in America. It's also because elite newspapers have hired lots of climate reporters, like the folks who wrote in today's journal, which is fantastic. But it means that if you only look at the elite newspapers, you get a highly biased view of what people are really worried about. And that's a problem, because it means that we are overly attentive to the elite news sources and not enough attentive to the underlying politics of how do we put together and hold together action that really brings along the entire country. I want to just say a couple more things and then wrap up. I think we have to recognize that a lot of what you need to do to make deep reductions in emissions is deal with uncertainty. And I think I find I'll ask Lisa later, but I find my climate science colleagues are a little uneasy about uncertainty. We're very good at characterizing uncertainty. We're worried about talking about uncertainty to the public because we think that's going to reduce public concern and willingness to act on the problem and so on. And so we emphasize things that we really know, like humans are absolutely to blame for climate change. That's fantastic. Everything that's really transformative in the industrial system about how to eliminate emissions comes with massive amounts of uncertainty. Which technologies work? How do you put them together? How do you put together a deal and hold together a deal? And we have to recognize that that uncertainty is central to the strategy that companies and governments are going to be following. Companies and governments are under a lot of pressure to say something about climate change. The CEO goes to Davos, the CEO wants to look green, then go back to the Gulf Stream, gas it up, go home. So you want to say something, and what does the CEO say? The CEO says we're going to be net zero by some year, usually 2050. In fact, half of publicly traded, this is incredible data from the Financial Times, half of publicly traded firms now have net zero targets. Outside of pulp and paper, which involves growing lots of trees, and so it's pretty easy to do net zero because your photosynthesis is helping you out. Outside of pulp and paper and a couple of other narrow industries, the vast majority of these companies have no clue, no idea of how they're actually going to get to net zero. They're talking net zero. For a while they were buying carbon offsets, which were very cheap, and then people discovered that almost all the carbon offsets were bogus, so they stopped, or actually they haven't stopped doing that, but they'll be talking a little less about that strategy. Buying bogus carbon offsets is not a net zero strategy. You got to figure out how inside your company and your industry do we transform our business. And that is that seems like a hard problem, and when you get serious about it, it's an even harder problem. Let me give you an illustration from one industry, which is the aviation industry, where we're doing a lot of work now. Worry about aircraft, you think, well, the aircraft are burning jet fuel, the jet fuel is a fossil fuel, so we got to get rid of the jet fuel in one way or another. And that leads you to strategies like buying sustainable aviation fuel. All the sustainable aviation fuel in today's market comes from more or less from recycling fry later oils and so on. Although we eat a lot of French fries, that market saturates very quickly. So that's a fun strategy for the first few people who buy sustainable aviation fuel, but doesn't scale. So it's not, frankly, in my view, not relevant. It doesn't scale. And worse is that it turns out that aircraft affect the climate not just by the CO2 from burning jet fuel. This is a measure of the impact of the climate, that's the vertical axis, from different things that aircraft pollute. Here's the CO2 from burning jet fuel. Here are contrails, those beautiful clouds. Actually, with huge error bars, maybe it may have an impact on the climate that's 2 or 3 times greater than the impact of burning just the jet fuel, the CO2 from burning the jet fuel itself. Which tells you that not only do you have to change the fuel, but you may have to change the way the aircraft operate. And if you can't figure out how to change the way the aircraft operate, you might have to go to hydrogen or electric aircraft and so on. Who knows what's possible? And industry after industry, the further left they are on this S-shaped curve, the more they're grappling with, okay, now we're motivated to be serious about the climate problem, partly because we're worried about losing our license to operate in the Western countries. So we're motivated, but we don't actually know what to do. This book that Chuck Sable and I just came out with is about how do you deal with those kinds of problems. Let me give you one brief illustration of another industry that's very interesting these days, especially in Southern California, which is electric vehicles. How many of you charge a vehicle at night? Right. Why do you charge your vehicle at night?
It's cheaper.
It's cheaper and?
Not using it.
Less demand, and it's a whole lot more convenient because the vehicle happens to be at home at night.
Yeah.
Actually, if you're a teenager has your vehicle, it's probably not home at night. So it's convenient, and the current tariff structure rewards that. If we care about using electric vehicles to reduce emissions, it's the wrong time to be charging the vehicle. Why? Because in California, our grid is moving in the direction of solar. So we're going to be a solar-dominated grid. And so the power plants on the margin in the middle of the day are solar power plants, which have essentially zero emissions. And that's what's shown in this chart here. Here's the emissions, what's called the carbon intensity of the electricity supply, over time, different times of the day, real data. We want to get people to charge their vehicles here. 95% of charging happens right now here, because that's the way the tariff structure is organized, and that's what's convenient. We're actually running a whole series of experiments. I actually can't say very much about them because some of you might be using the UCSD network, in which case you're members of our sample. But we're running experiments on humans. We're pulsing them with information, with cash incentives and so on, to see what gets them to move their charging from home to various times of the day. This is an example in the electric vehicle sector where we just don't know what the right answer is. So I want to just emphasize, I want to wrap up and say just a couple things here. One is there's a massive shift right now, and you see it in the data on the technology, you see it on the spend. And that's very, very encouraging news. But investors are also not idiots. And they are very, very worried about replaying their last two experiences in clean tech, which were all disasters. That's what this article's about in the Wall Street Journal. They're trying to avoid what was called in Silicon Valley clean tech 1.0, where you put a lot of money into clean tech and then you saw your investments go flat. That is not a viable strategy for attracting what looks to be $3 to $5 trillion a year needed in investment for clean energy. The world is awash in capital. Capital is not what's short in supply. What's short in supply are business models that connect the capital to real projects where real private investors are going to go in there. And they're finding that success in renewables and electric vehicles right now. The key to long-term sustainability and scaling is getting other sectors to be involved with that. I want to just close by saying one thing. It's about leadership. We in California are thrilled. APEC's going on in San Francisco. Anyone's planning to go to San Francisco in the next few days, don't. It's chaos up there. It's there this morning. We're very excited about our leadership. But we have to remember that the climate problem is not just a leadership problem. It's not just about leaders going off and being smug because we're doing great things. It's about what I'll call followership. It's about leadership that creates new facts on the ground, and by creating new facts on the ground, you create new politics, new technologies, and then what you do as a leader becomes more widely replicated. And what I've been urging governments and firms to do is evaluate everything they do on climate, not through the lens of whether they're excited as leaders, but through whether their actions as leaders generate more followers. Let me show you, this is the last slide I'm going to show you tonight. Let me show you some data. 1990, 1/3 of global emissions came from countries that would end up being, or jurisdictions that would end up being reliable leaders on climate change. Think all of Europe, all of Japan, half of America, 2/3 of Canada, Costa Rica. Costa Rica is a great place, not a huge emitter, great place. New Zealand. Add those all up, that's 1/3 of global emissions. And had those countries at the time adopted a theory of change that would actually work, it's possible that just having 1/3 of emissions, global emissions, inside that leadership bubble would have had an impact. But they didn't. We spent 20 years with international treaties that were designed as legally binding agreements to tell everybody what to do, that didn't take this uncertainty seriously, didn't recognize that pledging is not enough. What you need is to experiment. You need to test new ideas, change create new facts on the ground, and that's better done in small groups rather than big groups. What we used to call coalitions of the willing, but then we used that term for the second trip to Iraq that didn't go so well. So we don't call them coalitions of willing anymore, but that's the idea, is small groups. But that didn't happen. And since 1990, here's 2005, we're just in the process of updating these data, so a few years ago, what's happened is that the wedge of leadership has shrunk. Why? Because leaders have led. And if you bring this up to the current day and project it out into the 2030s, the leadership wedge gets tiny. So the irony of the climate problem is that the more you do as a leader, the less relevant you become to the problem yourself, because your emissions shrink, but everybody else's emissions continue growing. So if leadership is not by itself going to fix the problem, it's followership's going to fix the problem. And all of us in our local actions to our global actions can be thinking about that, is how can we as leaders do things that raise the odds that lots of other countries follow along. I'll close by saying that I've offered tonight, I think, a hopeful vision for a new theory of change that's working, it's having an impact, but it is leaving a significant amount of climate change. The climate system is not friendly when it gets pointed in the wrong direction. Massive amounts of heat are building up in the oceans, carbon dioxide building up in the atmosphere. That process continues at a different pace than it would have been otherwise, but it continues and eventually it will turn. But along the way, we're in for a significant amount of climate change. And the debate, if you invite me back in 10 years, or maybe 2 years, the debate will shift. And the debate is increasingly around what do we do about those physical impacts of climate change? How do we manage those? And that's also an area where I think we know more than we really know. We think we know how to deal with, for example, substantial sea level rise, build bigger seawalls. At scale, those things often don't work. And we have to have other strategies, but we don't really know what they are. We have to experiment with dealing with the physical impacts of climate change, just as we're experimenting in dealing with controlling emissions. good news in all that is that motivated experimenters actually learn new things, and that theory of change works pretty well. So thank you very much.